name's Conor and I'm an AI researcher in Lyons. So how it started, as I was saying, it started in college where we were to carry out an assignment that was basically, it was a who's who in AI in architecture, and I decided that it would be a great opportunity to instead take it as an opportunity to try and develop a tool for a problem that I identified quite early on, which is, as many people are probably familiar, that even in college level, if you go and try to present a drawing, the first question you're probably going to be asked is where's your north point, what type of drawing you're drawing, and the likes, and then it kind of derails, and you're just kind of like, oh, but please, can you talk about the architecture side of it for a minute? So I decided that would be a great opportunity, that having identified a problem, to try and see if I could use AI to solve it. So what you're seeing there is a QR code to access the app I did at college, and just a little plan with some dimensions that I put on it to be able to test it. I don't know how good your camera will be able to get from there, but basically what it was is it was a proof of concept to be able to use an AI model trained on use of data, and could I get it as lightweight enough that I'd be able to run on a phone. If you can get working on your phone, you might notice that it's a video, so it's actually using your phone camera to scan it, and it does it 30 or 40 frames per second, which is great to know that it can run on. First of all, it's actually running, the model is on your phone, it's not being sent to a cloud or like that, the model is loaded onto your phone. So when you compare it to the likes of GPT or anything like that, you're never going to be able to get a GPT model onto your phone for now. But like, to be able to get a model that small is quite interesting. So as a proof of concept, like, you will be able to develop AI tools at college level and upwards to be able to run lightweight on all your devices. So where that links into Lyons, is Lyons is on a similar enough path in that they were they were looking at developing their own tools, but also developing their own uptake in AI. So it made sense that, based on the conclusions of my research, was that it was very hard to be able to do this without access to data, structured data that's consistent. Which the conclusion of the paper, that it all comes back down to that. The models are there, but in terms of architecture in Ireland, it's very hard to put together a data set. There's no data set that exists typically for architecture yet, compared to other industries. Like I've seen a few for medical, would be a big one, or other areas where they would have data sets for this sort of thing to be able to experiment on. So why we want we want to build a model like this? Well, of course, it's, you have clear audit trails, you have full control of your workflow. You can control what is being fed to a certain model. You can control where that information goes. If it runs on local machinery, the data never leaves the office. It's never sent to a cloud. You don't have to worry about third party having access to information when you're able to develop these tools. What my research demonstrated, you might be able to see below, is how the machine interprets, or the AI interprets the drawing. So drawings are inherently structured data. They're just structured for our interpretation, not a machine's interpretation. So it's to take a drawing like this at raster format, so you can work on, if you want to scan a drawing, photocopy a drawing and feed it to the model or show it to your camera, as you can see. It'll then convert the information over into machine format, which allows it to be database ready, so that you can get your drawings then, and then you're able to query them. So this is great for things like control, and just besides that, even if you don't develop these tools to use, you're actually building up your AI literacy within the firm, so that when you do go to a software provider, you're able to act more as a collaborator with them rather than a customer. So you're able to interpret what problems they're having, or where would be the areas that they'd very easily be able to improve when they're tailoring their software. And we found that typically when it comes to software providers, they actually are more often relying on your advice rather than you are relying on them to build these apps now. So what you'll have is they're more willing to help train you and upskill you, because in the process they're actually learning how to make their app better or their software better. So sorry, I didn't explain what is happening. So this is what the model sees in the background. What it's seeing here is a drawing, and you're seeing the overlays of the various categories. So it's identifying various things. And what you're seeing as it's doing that is, instead of the likes of ChatGPT and the likes which will say, oh, there is a drawing on that sheet, it'll actually give you a percentage score where it says, I'm 97% confident that's the drawing, which is great because that's transparent. You can understand straight away, okay, I can trust that. Or, for example, if I'm able to identify, well, it's not particularly great, this particular type of element in a drawing, I can then go back to my data set and refine it in a way that makes it better, and then I can audit that and go from there to make it better as a tool. So then I just got the model and put into a basic workflow. So this is typically how it works. User creates a drawing, it goes into the data, the AI model then pulls the data from it, and then what we can do is various different things you can do with structured data. Once the drawing is structured and the data is structured, you can do any number of things, and the more I talk to people about this, the more different conclusions everyone comes up with. They say, oh, I can use it for clash detection, or I can use it for pulling information off drawings. I can see everyone comes up with different solutions or conclusions to a tool like this. But the one I always go to is the validation, because it was the one that I started with, so it's the one I continue on so that I can track progress a lot easier. So the workflow I developed a software around it so to be able to interface with the model, because typically when you're doing this type of research with AI, no one wants to see you using a command line screen, because you lose 95% of people. As soon as you start showing them code, you lose them. So you typically have to show them in some sort of interface. It's the best way to show software to people. So I developed a small little app, and what it goes through various stages, and when you get to the end, you're able to do anything, a number of things. You can do drawing searches in your database. So I suppose a lot of industries you'll find as well, like you'll have people like graduates like myself who would rely on the tacit knowledge of their superiors to say, can you help me find a detail that you've done before for X? Is there an example of Y? So what you're able to do then is, if you have all your data in a database format, you can search it. You can search, say, can you find me details for this? Or if you want to provide an LLM with access to said database, you're able to then have a database that, instead of pulling it from the internet, it's actually pulling it from your own data, which is great, because that means it will be okay, because it's coming from the right source information. It's not making things up, typically, if you're that way. And you can do automated documentation, because you have all the data is converted over. You can do things like, if you wanted to generate issue sheets or Excels, you can do that because the data is already converted over. So that's great as a solution. So then that would be the interface of the UI I was telling you. So the idea would be on like a second meet, for example. So it's a very simple interface. The main points are, you can see the drawing, you can see the various categorization. That's for your own backup to see, is it actually working that way? So instead of blindly trusting the outputs, you can actually see its thought process visually. And to the right then is the information that's pulling out of it, so the general information, but it's also, as you can see on the bottom right, giving the recommendations saying, why don't see this based on validation rules that you can create yourself. So it knows it's then looking at a plan. It applies a set plan rules that says, when I'm looking at a particular type of plan, I'm expecting to see X, Y, and Z. I only see X and Y, you're missing Z. So it won't, as a design, we said, we're not getting to automatically make changes. It's an assistant, it's not going to be your colleague. Typically for any AI solution, I don't think it should ever be your colleague. So it points to something because it may be wrong, so you don't want it to make changes on your behalf. So it's better to recommend something. So let's say it doesn't see an R point, for example, but there is one. It doesn't add a second R point, for example. It just highlights the fact that maybe that your R point isn't clear enough, because the model doesn't see it. Chances are it's probably a very small R point, it's not very visually prominent, or you're using the wrong type. So the model performance, a study by AEC found that even the most up-to-date LLMs score quite low in their ability to read architectural drawings. Their study was to do with doors, windows, symbologies on plans, and their accuracy average was 41%. My model, in terms of our outputs, averaged 96%, which is more than double. So it's quite good to see. It also runs lighter. The reason this is because our industry is with very closed data, which is to our benefit in regards to the likes of the large LLM companies don't have access to this data, they can't train on it, so of course they're going to perform a lot worse. But when we provided architectural data only, it can only ever pull from architectural data, so it's not going to make up something that's vaguely related to it. Like you'll notice a lot of times when you're asking about a person or text, because it has creative data in it as well as informative data, sometimes it gets confused what you're asking it to do, whereas if it only has informative data, it can never make up creative data. Yeah. So what you see here then on the left side then is the comparison. So token comparison there. So when they got the text extraction, so which is the next layer above, so it identifies certain elements of text and it also extracts it and converts it into text that's useful then. So you see in the top then is the standard LLM, which is averaging about 294 words, whereas mine was able to pull 541 words from the drawing. Also, the LLM is unstructured, so it outputs information in an unstructured format, and that they're always conversational. So it's oh, I see this, I see that, which is great for when you're asking in one drawing. But when you're trying to get into a database format, it doesn't have a particular type of schema, which is how it's translated into a database. Whereas mine goes this equals that, which means that it's much more easy for machine to read. The end goal isn't that it's for you to read because you have a drawing to read, so why you don't need to be able to read the output, it's for a machine to read it. The reality of doing these things is that they take a lot of time. The drawings, there's 375 drawings in the database, which actually sounds like it's not a lot, which it isn't when you're comparing it to LLMs, which have millions and billions of data entries in them. But that's not necessary if you're looking at for a small particular task, and you only need to do that small particular task, you only have to give it information on that task. And that allows it to be very accurate, and it'll narrow its range of operation to what you want it to do. The problem is that in terms of training, it starts off manual, you do about maybe 100 drawings in a week, and then what the model will actually start to learn what you're asking it to do, and then it'll go to 100 drawings a day. And then once you get to 100 drawings a day and it starts to be trained in, you'll find that the model is actually quicker than you're able to provide it information. So as quick as you're able to provide it information, yeah. The only problem we found there was the subjectivity, which is actually an interesting point in the ambiguity of some of the text inputs. Even as you're annotating the drawing, sometimes when you're reading text notes, it might be ambiguous what kind of note it is. And the model actually will represent that in itself. So it actually starts to demonstrate a lot of the things that you feel like yourself. Like you know an arc point is an arc point, you know a text block is a text block. But when you're reading a particular type of note in the drawing, is it a revision note, is it a spec? Sometimes it's a bit ambiguous, it can be somewhere in between. And when you get to that, the model is exactly the same. It'll output exactly what you give it. So that's a big point to think about that is they're only ever as good as the human who's training them. I don't think there'll be ever a stage where they'll ever be better because they only can pull from the information they're provided. Also, when you're thinking about doing these types of tools, it can actually be quite risky to develop these tools. Beyond proofs of concepts, like proof of concepts you can do in a week, but to actually develop software to the point where you can use it in production involves a lot more than that goes into the background of software. If it was a case that you could develop these things in a week, the likes of Amazon, Google, they wouldn't have design teams anymore. It's that you have to put a lot more man-hours in it than you think. It's also quite risky to develop these tools because when you go to develop them, 6 months down the line, you're halfway through developing this tool, the next model will come along and they can do it, which is quite risky at the pace of development. But when it comes to developing these tools, what you do get, and it can never be taken away from you in anything, is the knowledge you gain through learning these things, so that when you do go to a software provider and you say to them, look, we're quite interested in your tool, they don't treat you as a customer, they know you can develop tools that are equivalent to theirs, which is great because then you're no longer, as we were saying earlier on, you're no longer a customer, you're a collaborator in the process, they'll take you more seriously and the tool gets better as a result. So just to close off then, I have a few points on what this means for practice. So expanding on what drawing data can do, as we said, if you get that and it to be structured for machine, you can do any number of tasks. I'm sure you can all think of thoughts yourselves of how you'd want to be able to have machine access to your data. It's quite good for the industry if you're able to get to that point. So in regards to the evolving skill set, so as you can see, graduates now are learning with AI. They've been in college with AI from a very young age, and as many of you are probably aware that they're quite good at hiding the fact that they're using AI, which is a skill that you never would have thought that you needed, but it's very much relevant to the industry. I'm sure you've seen many news articles of people getting caught using AI at very high levels because their references are not real, or it would be caught using EM dashes or things like that. Graduates have been around with it so long now that they know how to use it properly, which is great because they're able to advise senior staff members on how it's used, which is great. We're also seeing that because we're able to develop our own software, we're actually reducing our reliance on vendors. So the likes of Adobe or Autodesk, you're actually being able to, who would typically impose, say, here's our tool, you can use it or you can't, learn how to use it. So you're actually adapting the software to suit your workflows rather than the workflows to suit the software. So you're able to be a lot more collaborative with them, especially to the very big companies who typically don't really want your input that much, they just want you to use the tool and pay for it. But the only problem with open source tools is that they carry risks. You have to be this is where the skill set comes in, because you have to be very good to identify, okay, where is the data going? How dangerous is this? Is it high risk use of AI? You shouldn't be using LLMs, let's say, to query the technical guidance documents. You should be still in the position that you're doing that yourself. So I'd say to learn that skill set, to not trust an AI output at face value, and to see, okay, well, as you're seeing with the model, sometimes it's 50% confidence, sometimes it's 99, sometimes it's 100. You get to have that kind of ability to see how do these AI models think, which is great, because then you can understand what they're good for and what they're not good for, which improves your responsible AI use overall, across the board for any AI use. So the road ahead then for us, so if visual language models, their capabilities emerge, we'll know how to we'll understand and use them better. So tools like mine, when eventually that becomes obsolete, because of course it will eventually, probably by February, March, it'll be obsolete, because the new models we've seen, like Gemini 3, it's actually quite good at being able to read drawings now. We'll understand them, and we'll actually understand better that, when it says I see something, we'll know, okay, it's probably not that confident in how it sees it. We're also seeing that these models are getting quite good at understanding spatial intelligence. We're seeing certain softwares now, like even your image models, the Nana Banana, you're able to give them an image of a facade, and you're able to say, give me a section detail through that facade, and it'll start to put in all the specifications in it. They're not 100% right. I wouldn't send it out of the office, but it's a great test to be able to see that in a year or two's time, like it's going to get to a point where you can ask it for a model, and it'll probably give you a good starting point of a model. We're also seeing the resurgence of AR and VR technology, which is another area that's great. We're testing software a provider called World Labs, which are able to provide an image or a series of images, and from the series of images, it's able to actually put together a Gaussian splat of the room. So let's say if I was standing in the room and I was taking pictures of the four walls, it's able to picture them together, pierce them together, and it's able to create a visual representation of this room that you're able to walk around in a VR headset, which is a great use of it. We're also seeing the videos are getting quite good now. The images, they're very good. There's a point now where we were having a conversation yesterday, like, what does an architect actually provide now? If clients are going to come to us and start saying, that's my building, I want it, what do we as architects actually provide as a service then? So it's about understanding, like, how does this affect the business? So the key takeaways, AI of course remains consistent. It can allow us to have more time for creativity. The way I always describe it is, when you're using AI, imagine you have 10 hours to do a project as an architect. How many of those hours are actually for the creative process that we all wanted to be architects to do? Maybe 2, if we're lucky. And the rest is documentation and the likes that have all typically been imposed upon us as architects. So to be able to direct the AI and say, no, you're not getting any of the creative process, that's always going to be for us. We're going to direct you at the documentation, parts we don't like of our job. If you can reduce that, what we get is, there's different ways of looking at it, but if you have more time for the creative process, you can either take on more jobs, the undesirable is hire less staff, or you can do more creative time. So the end result is better. So you can have some more time to talk about, and which is great for graduates as well, because the general consensus when you come out of college as an architectural graduate is you're not going to spend your first few years actually being an architect. You're going to be doing a lot of the CAD work side of it, and you're not going to get a chance to be creative, which is great now because these tools are reducing the time it takes to develop the documentation. You're actually allowing people a lot younger to be able to get involved in the design process, which is great to see for the industry. So I think the AI can actually be good when used responsibly or correct. And then when you're seeing the tools being developed now, is that it allows us to develop software that suits our workflows. So let's say you wanted to change from ArchiCAD to Revit or vice versa. That's a major business decision. But what we're seeing now is that we can have tools that we can say, okay, we don't like that particular part of our workflow, it takes too much time, and we can develop a tool that can help solve that problem. It doesn't have to be production ready because it's in-house, it can be clunky. It doesn't particularly matter, because when you get to a stage where you want to sell it, that's a whole other area, especially in terms of regulation under the AI Act in Ireland. As soon as you start providing your software, it's into a different set of rules. It's a grey area. We're seeing in teams now that people are starting to develop their own software. So instead of roles like myself saying, here's a tool, use it if you want, I think it's great, you may not. We're actually starting to see, because of the literacy, which is the main thing, is that we're seeing various people on our team saying, I don't like that part of my job, I have a bit of free time here, I'm going to try and solve it based on the literacy or the AI. And then you might guide them on that, instead of saying, here, I'll solve your problem for you. You're guiding them and saying, okay, I don't like your use of AI to do this, I do like to do that, but it's great to see. We noticed in Henry Jays recently that in terms of our own LLM provider that we've had, in terms of our token usage for the years, we've used 900 million tokens, which is about 600 million words. Yes, for this year, in terms of our provider, which is about 600 million words across the practice. We all have access to our own provider. It allows us to do a number of different tasks. We have different tailored workflows that are built around it. We're also, with our image, we use software called Create, other ones exist, Midjourney, the likes, that allows us to generate images and generate workflows. That one was another one that we burned through our credits very quickly. Sorry, because we have a corporate account, but you burn through them very quickly. But it's great to see the numbers of people that were using it. We started off with a team of 5, maybe in July, now we're up to 50 or 60 people using the image daily. But when it comes to the LLMs, it's used, I'd say about 80% of the office use them, using it in their own particular way. So that's...
Thanks, Conor.